Hello, my dear students. In the last class, I explained about principle of superposition, how to split up the forces for uniform cross sections. Right. Today, we will discuss some more problems on uniformly varying sections, how to find the deformation, how to split the forces, how to apply the principle of superposition. Let us take one example. A steel bar ABCD 4 meter long is subjected to forces as shown in figure. Find the elongation of the bar. Take E, Young's modulus for the steel as 200 GPa. Okay, this is the figure given. So here you can see the forces are acting at different edges and the bars of uniformly varying sections, right? So what are the given points here? The total length of the bar is given, that is L is 1 plus 2 plus 1. Totally it is 4 into 10 raised to 3 mm. Meter you can convert into millimeter. Okay, first let us consider only the first part, L1 that is equal to 1 into 10 raised to 3 mm. Then L2 that is 2 meters, or 2 into 10 raised to 3 mm. Then for the part C, again L3 is equal to 1 meter, or 1 into 10 raised to 3 mm. Then D1 is 15 mm diameter, and D2 is 20 mm diameter, and again D3 is 15 mm diameter. Okay, Young's modulus is given. First we will calculate the area. See, A1, this is the section 1 and section 2, and for the section 3. A1 and A3 are same because the diameter is same. So, area A1 is equal to A3 is equal to pi divided by 4 into D1 square. What is D1? D1 is 15 mm. So substitute, you will get 177 mm square. Then area of the middle portion. What is that? A2 is equal to pi divided by 4 into D2 square. What is D2? D2 is 20. So substitute, you will get 314 mm square. Okay, next you have to split the force. How you can split the force? See, this is the given diagram, right? Here, this 20 kilonewton is acting at A, and 5 kilonewton is acting at B, and at C 10 kilonewton, at D it is 25 kilonewton. How you can divide? The first thing, you can consider this A and D, because here it is 20 kilonewton, here it is 25. So you can split 25 kilonewton at D into two forces. How you can divide? That is 15 into 10, right? Then similarly, the force 20 kilonewton acting at A, it may also be split up into 15 and 5, because at B it is acting, the force is of 5 kilonewton. Okay, so how now totally how we can divide? See here, now it will be seen that the bar AB is subjected to a tensile force of 15. So first I divided at A, the forces are split up into 15 and 5, because at B the force acting is of 5 kilonewton. So you can consider AB first. Okay, section AB. So that is 5. You can split the forces, both are tensile forces. Now at A, that is remaining is 15. Okay, so now B over, there is no forces. So if you consider CD, how you can consider? If you split the force 25 kilonewton and D into 10 and 15 kilonewton, so that CD you can consider, that is 10 and 10. Okay, now remaining at D is 15 kilonewton. So at A also it is 15 kilonewton. So you can consider the bar A to D means it has to go through B, C. Okay, so at A it is now 15 and D also 15. But this is not a uniform section. Okay, you cannot consider it as like a straight line, because it is diameter is different. Section is of different diameter. So you have to consider like this. Now how you can calculate the deformation. I think I hope all you have understood this, right? So once again, if you want, I'll explain. So at A, the forces may be split up into 15 and 5. So what you will get, AB is 5, 5. Okay. Next, BC is again, B you cannot take BC because already B at load is used, so there is no load at B. So CD you can take, that is 10, 10. So remaining load at D is 15. So at A also 15. So you can consider AD. So three deformations you have to consider. A, B, C, D one section, then A to B other section, and C to D other section. So what is total deformation? Total deformation is equal to delta L is equal to delta L1 plus delta L2 plus delta L3. What is delta L? Delta L is equal to PL divided by AE. Here always I tell, and even I have told also, when you apply the deformation formula, that force has to be same at both the ends. So now you can consider, first we will consider this load, okay, this section ABCD. So what is that now? ABCD, so this P is 15, right? So you can keep it outside P, and E also common, you can take outside. So then what is the remaining term? L1 divided by A1 plus L2 divided by A2 plus L3 divided by A3. Right? Substitute here P is equal to, now first this section, that is P is equal to 15. Okay, 15 into 10 raised to 3 kilonewton, convert into Newton, into divided by Young's modulus, 200 into 10 raised to 3. Okay, L1 for this is 1 meter, L2 is 2 meter, and L3 is 1 meter. So substitute that 1 into 10 raised to 3 divided by area. A1 is, what is the A1? A1 is 177. So substitute that. And plus L2. L2 is 2 into 10 raised to 3 divided by area A2 plus again L3. Substitute. You will get 1.32 mm deformation. Okay, this is the tensile force. Next, one section is over. Go to the next section, that is deformation of the bar. This one you can consider now. B and A and B. Okay, so this, because here you used only 15 kilonewton, so there is 5 kilonewton load is left out. So you can consider the bar AB. So what is that? That is A and B. B at AB is 5. So 5 and 5. So but here you can okay, this is also tensile force only. So consider that delta L2 is equal to P to L2 divided by A2 into E2. P but E are same, so we can keep it outside and substitute. Okay, so you will get this answer. Next, consider the next bar. What is the next bar? Next bar is CD. This section, that is 10 kilonewton. So apply that formula. Delta L3 is equal to P3 L3 divided by A3E. Okay, substitute the values, you get this. So now you got delta L1, delta L2, delta L3. So total elongation of the bar ABCD is equal to delta L is equal to delta L1 plus delta L2 plus delta L3. So substitute these values. 1.32 plus 0.14 plus 0.3 is equal to 1.74 mm. So in this way you can calculate the deformation by applying the principle of superposition for the uniformly varying sections, right? We will see one more example. A member ABCD is subjected to forces as shown in figure. find the total change in the length of the bar. Take E for the steel as 200 GPa. Okay, this is the figure given here, A, B, C, D. Okay, this area is given 300 mm square. This area is given 500 mm square, and this area is given 400 mm square. The loads are acting like this. Okay, at A 10 kilonewton, at B 40 kilonewton, at C 50 kilonewton, at D 20 kilonewton. The lengths also given 200 mm for A to B, B to C 600 mm, C to D 200 mm. How you can split up the forces now here? See, at A 10 is there. So if you consider AB, it becomes 10 and 10, right? Now here remaining is 30. So consider BC here 30, 30. Okay, this is compression force. Next, C, what is the left out is 20. So you can consider CD 20, 20. So very easy this one. So easily you can split up the forces, right? First AB, that is 10, 10. Next BC 30, 30, and then CD, it is 20, 20. Okay, so total deformation is equal to delta L1, this one. Apply this section formula. Delta L2. What is delta L2? This is compression force. So I have told for tensile force you have to consider positive sign, and for compression force you have to consider negative sign. So delta L is equal to now delta L1 minus delta L2, because this is the compression force, plus delta L3. So use the formula. What is the formula? Delta L1 is equal to P1 L1 divided by A1 E1 minus P2 L2 divided by A2 E2 plus P3 L3 divided by A3 E3. Here all are of single cross section, right? It was not like the first problem. There was what, A to D, it was of varying section. So you had to consider the deformation is equal to at different sections, but here all of uniform sections A, B, B, C and C, D. So directly you can consider. So you will get this answer. You try this and cross check the answer. I hope now all of you understood this concept of principle of superposition. Okay, now in the previous class I have given that assignment, that was assignment 1A, that is finding the deformation for using principle of superposition for the uniform cross section, right? Today we will say you have to solve some more problems, both finding the deformation without using the principle of superposition and with using the principle of superposition. The first problem is like this. Here you no need to use the principle of superposition because only one load is acting at the ends. Okay, find deformation, and here also no need to use the principle of superposition, and here you have to split up the forces and use the principle of superposition and find the deformation. Okay, and one more problem is there. Here also no need to use the principle of superposition. Directly you can find the deformation. Okay, and one more problem. Just read out and do this problem. At the end of this class we will discuss about this. If you have any doubt, you can ask during that time. Hope all of you understood this. So next class we will go to the next chapter, that is the bars of composite section. Thank you.